Hi, I am Yasar Arafath. I am here with another maths video for Class 10 CBSE students. I welcome all of you to this video. In the last video, we have started the topic areas of similar triangles and we discussed one theorem, very important theorem. This theorem, the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Those who didn't watch that video, I have given the link to the playlist of triangles chapter in the description below. If triangle ABC and triangle PQR are similar, then we can write area of triangle ABC by area of triangle PQR is equal to AB by PQ all square is equal to BC by QR all square is equal to AC by PR all square. The ratio of areas of these two triangles, they are similar, is same as the squares of ratios of corresponding sides. Now we are going to do some exercise questions based on this theorem. These are the questions we discuss in this video. First two questions from exercise 6.4. Let's read the first question. Let triangle ABC is similar to triangle DEF and their areas be respectively 64 cm square and 121 cm square. If EF is equal to 15.4 cm, find BC. There is no figure given. Actually, to do this question, there is no need of a figure. But anyhow, to make the question clear, I shall draw some rough figure here. Suppose this is triangle ABC and this is triangle DEF such that they are similar. Given that area of triangle ABC is equal to 64 cm square and area of triangle DEF is equal to 121 cm square. Also, given that EF is equal to 15.4 cm and we want to find out BC. This is very simple question. You can expect such questions for 1 mark or 2 mark. Very simple. So what we have to do, given that these two triangles, triangle ABC and triangle DEF are similar, so we can apply the theorem we just discussed. What does the theorem says? If we name the triangles like this, by applying our theorem, we can write like this: since triangle ABC is similar to triangle DEF, we can write, we have, by applying this theorem, we have area of triangle ABC by area of triangle DEF is equal to what? The theorem says that this ratio is same as the squares of ratios of corresponding sides of these two triangles. So it will come like this: BC by EF the square all square is equal to AB by DE all square is equal to AC by DF all square by applying our theorem. But actually we don't want the second and third. We need only BC by EF, because here in the question EF is given and we want to find out BC. So we don't have to take the other sides. So I am rubbing this last two. I wrote those two also to make you the concept, the theorem clear. Now this is enough here to answer this question. So here we can substitute the given values. Out of these 4 values in this equation, 3 of them are given. Area of triangle ABC is given, area of triangle DEF is given, BC is not given but EF is given. So by substituting the given values, we can easily find out the value of BC. Let's do here. Area of triangle ABC is 64. So 64 by area of triangle DEF is 121 is equal to BC, we don't know, so simply write BC by EF. EF is given that 15.4. So BC by 15.4 all square. In the next step, we can write 64 by 121. We cannot reduce this fraction because 64 and 121 are co-prime numbers. Otherwise, we want to convert to decimal number. We don't do that now. Okay. Is equal to BC square by, we can split all square. So BC square by 15.4 square. So in the next step, we can write this 15.4 all square, we can move to LHS. So it will become 64 by 121 into 15.4 into 15.4 is equal to, on right side, but remains BC square. So can we reduce this? Look here, 15.4 and 121. So let us consider this 15.4 are 154 and 121. Are there any common factor between 154 and 121? Any common factor? Yes, 11 is a common factor, right? I shall show you one website now. That website you can use, not in the exam point of view. This is the website, co-prime calculator. Here you can find out the common factors of given numbers. You can type numbers here. So to get the common factor of 154 and 121, you want to enter numbers 154 and 121 here. So you will get one common factor, that is 11. So they are not co-prime. So these two numbers can be divided by 11. I showed this website not in exam point of view, but I hope this will be useful those who are very interested in mathematics. So 11 is a common factor, but here actually this is not 154, this is only 15.4. So we can write like this. If you divide in 154, 14 11s are there. So in 15.4, if you divide by 11, you will get 1.4. And in 121, we all know 11 11s. Again this 11 and this 15.4 you can divide. Here how many times? 1.4. Now what remains? BC square is equal to 64 into 1.4 into 1.4. So if we do direct multiplication, what we have to do? 64 into 1.4 into 1.4, then take the square root, you will get BC. But I will show you some more simple method. So 64, we all know 64 is 8 square. So 64 can be written as 8 into 8, then into 1.4 into 1.4. That is equal to BC square. In the next step, I write this product as 8 into 1.4, again 8 into 1.4. So this can be written as 8 into 1.4 square. That is equal to BC square. So squares can be cancelled. So you will get, I turned the equation also. So we will get BC is equal to 8 into 1.4. What is 8 into 1.4? I think you can multiply in your mind. We know 8 into 14, if you multiply you will get 112. So 8 into 1.4 will be, you want to put point one place to left, so you will get 11.2. Unit is centimeter. That is the length of BC, the required length, 11.2 centimeter. I explain the answer once again. So our question is, two similar triangles are given, namely ABC and DEF. Given that two triangles, triangle ABC and triangle DEF are similar and their areas are given and one of the side is given. We want to find out one side of other triangle BC. So we drew some rough figure. Actually no need of a rough figure, but I drew here to make the concept more clear. So it's very important to take corresponding sides. So we know similar triangles are named according to the corresponding angles. So from the names we will understand angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. So in the ratio, if you take the ratios of corresponding sides, it will come like this: AB by DE, BC by EF, and AC by DF. But we need only one, that is BC by EF, and by theorem we know the ratio of areas of these two triangles, they are similar. Here you can see area of triangle ABC by area of triangle DEF, that is equal to square of the corresponding sides. So we can write BC by EF all square. We don't want to take the ratios of other sides. So this is enough. Then substitute the given values and simplify. We will reach into the final answer 11.2 centimeter. Okay, that's all the first question. Now we can discuss the second question. Okay, question is like this: diagonals of a trapezium ABCD with AB parallel to DC intersect each other at the point O. If AB is equal to 2CD, find the ratio of the areas of triangles AOB and COD. There is no figure given, but we can draw some figure according to the given statements. So how will the figure looks like? Rough figure enough. One trapezium ABCD with AB parallel to CD. So the figure will be almost like this: one trapezium. Name, how we want to give name? AB is parallel to CD. So ABCD. Now it looks like AB is parallel to CD. Also I have drawn almost satisfying the second condition given, that is AB is equal to 2CD. AB is equal to 2CD. Then it is said that the diagonals intersect at point O. So I draw the diagonals AC and BD, and for the intersecting point I give some name O as given. Now the question is to find the ratio of the areas of triangle AOB and triangle COD. These questions are just after the theorem we studied. So you can expect in some way there will be some possibility to apply our theorem. So these are the triangles we want to find the ratios of areas. These two triangles, triangle AOB and triangle COD. For that, to apply our theorem, can we prove that triangle AOB and triangle COD are similar? Can you prove? They are similar, right? How we can prove that? Triangle AOB is similar to triangle COD. So look here, in these two triangles, these two angles are opposite angles. They are equal. And also since AB is parallel to CD, these two are a pair of alternate angles, and these two are also alternate angles. That means all three angles of these two triangles are equal. Therefore, by AA criterion, these two triangles are similar. Then applying our theorem, we will reach into this result. We can find out what is asked to find out in this question. So let's do here. Consider triangle AOB and triangle COD. Angle AOB is equal to angle DOC since they are opposite. Then angle OAB is equal to angle OCD because they are alternate. Actually this is enough. By AA criterion we can say no need to go for the third angles. So we can write, therefore triangle AOB is similar to triangle COD. The reason you can write inside bracket by AA criterion. Since they are similar, by applying our theorem, what will we get? The ratio of areas of these two triangles, that is area of triangle ABO by area of triangle COD is equal to the squares of ratios of corresponding sides. But we don't have to take all three pairs of corresponding sides, but we have a target, so we take only the corresponding sides A, B and CD. They are corresponding, right? They are opposite to equal sides. So we write this ratio of areas is the same as AB by CD all square. That's enough. Now we can substitute this AB is equal to 2CD here. So it will come like this, is equal to 2CD by CD all square, and here CD can be cancelled. So now it remains only 2 square, that is 4, right? So we got the answer. The ratio of areas of these two triangles is 4, or we can say 4:1. I shall explain once again. Our question was there is a trapezium ABCD, AB parallel to CD, and their diagonals intersect at a point O. So we can draw some rough figure like this: AB parallel to CD, a trapezium, and their diagonals intersect at O. And given AB is equal to 2CD, then we want to find out the ratio of areas of these two triangles. So for that, first we want to prove the similarity of these two triangles. It's very easy. By AA criterion, we can see that these two triangles are similar, because here one pair of angles are opposite angles and two pairs of angles are alternate angles. So by AA or AAA criterion, we can say that these two are similar triangles. Then we can apply our theorem. The ratio of areas of similar triangles is same as the squares of ratios of corresponding sides. So we will get area of triangle ABO by area of triangle COD is equal to AB by CD all square. The next line we can substitute 2CD for AB, then we can cancel CDs, then it will become simply 2 square, that is 4. So the ratio of areas of these two triangles is 4, or we can say 4:1.